If you ever get the chance to stand next to the Gloster Javelin, I highly recommend it. I was recently at the Midland Air Museum in the UK, where they have a javelin that dwarfs the nearby Vampire and Meteor. It is almost impossible to appreciate what an imposing, great beast of a machine she is until you're up close compared to the sleek Hawker Hunter sat close by. However, as imposing as she may be, she is not well known or even loved by the public as some of her contemporaries, like the previously mentioned Hunter. Envisaged and designed to be a bomber-destroyer in the 1940s, she filled an important role for 12 years as the RAF's most heavily armed night and all-weather interceptor until the English Electric Lightning took over. Tasked with chasing down, albeit subsonically, and obliterating nuclear-armed Soviet bombers with her 430mm Aden cannons, and later on Firestreak air-to-air missiles before they could penetrate UK airspace, should war be declared. She was appreciated by the crews who flew her, and was seen as a huge step up from the Meteors and Venoms in capability and performance, proving valuable in the Indonesian-Malaysian confrontation, and providing air support following Rhodesia's unilateral declaration of independence in November 1965. However, her development was, without a doubt, convoluted and difficult, and it wasn't until 1956, almost a decade after the initial requirements were drawn up, that she finally entered service as the first all-British delta-winged fighter in the RAF, and incidentally, was also the world's first twin-jet delta. Some early models were criticized for being underpowered, hard to fly, and too slow to intercept targets at altitude. They also had a habit of ejecting their pilots without warning, along with engines that exploded when being started or even tearing themselves apart when flying in clouds. Her flaws as an interceptor earned her a poor reputation and some unflattering nicknames, such as the Flatteron, Dragmaster, and Flying Flat Iron. In this video, I want to explore this forgotten warrior of the Cold War, and see if I can help shine a new light on her, one that I believe she deserves, because, in my humble opinion, she is mostly, definitely an unsung hero. So, make a nice cup of tea, some jammy dodges, and let's dig into the story of the very British Javelin. After World War II, Britain still relied on night fighter versions of the de Havilland Mosquito, equipped with the American AI-10 radar to patrol her skies. Despite the Mosquito being a formidable machine during the war, rapid advancements in aeronautical technology quickly rendered her outdated. At that time, the Soviet Union had managed to clone the Boeing B-29 Superfortress by reverse engineering several of these American giants that had crashed in Russian territory to create the Tupolev Tu-4, which would cruise at 311 miles an hour at 36,000 feet. And the thinking was, if the Soviets had the know-how to build these giants, then how long would it be before they removed the piston engines and replaced them with jets? Coupled with the awesome destructive power of the atomic bomb, the fear was that it would only be a matter of time before the skies above Britain would be swarming with high-performance, high-altitude nuclear-armed Soviet jet bombers, like the soon-to-be Tu-16 Badger, lit aflame under the Air Ministry. Personally, I've always thought that the Allies overstated the Soviet capabilities and understated their own in order to sensationalize, forgetting the obvious challenge of crossing Europe undetected. Early jet engines had several limitations, the most serious being high fuel consumption and the need to operate at high altitudes for maximum efficiency. If this was true for the Allies, then it must be true for the Soviet bombers. What do you think? Let me know in the comments. Anyway, with the perceived Soviet threat of high-altitude bombers in mind, in January 1947, the Air Ministry released two separate specifications, F.43-46 and F.44-46, to revamp Britain's air defences, although it can be argued that the Javelin's lineage can be traced back to earlier Gloster proposals. However, for the sake of my sanity, and as you will soon see, yours too, we'll use this as the starting point. F.43-46 outlined the requirements for a highly maneuverable single-seat day interceptor, with a high rate of climb by getting to 40,000 feet in under 6 minutes from engine start, and a service ceiling of 45,000 feet. Just in case the bomber was getting away, armed the interceptor with a 10-foot-long recoilless 4.5-inch gun designed to absorb the recoil by firing a counterweight backwards when the shell was fired. The second specification, F.44-46, covered the details for a two-seat night fighter armed with four 30mm Aiden cannons and a maximum speed of at least 600 miles an hour, with a cruising speed of not less than 500 miles an hour, and to get from engine start to 45,000 feet within 10 minutes, plus have an endurance of 2 hours, and with 15 minutes for combat. So, it was important that the engines could be fired up in only 5 seconds from the pilot getting the order to scramble. The required kit list included an airborne interception radar, a blind landing system, navigational aids, a jettisonable cockpit canopy, and ejection seats. On top of all that, the aircraft had to be economical to produce, at a rate of 10 per month, and easy to service. What followed was a bewildering shuffling of specifications and design submissions from multiple manufacturers. But to keep things simple, we'll focus on the designs from Gloster Aircraft, who was seen as a natural candidate to develop this interceptor, seeing as they had pioneered jet-powered flight in the UK with the experimental E.28-39 and the twin-engined Meteor, the first and only Allied jet aircraft to have fired a shot in anger in World War II, hunting V-1 flying bombs. Gloster design team, under George Carter, and with chief designer Richard Walker, who was responsible for almost the entire program, made project studies for both specifications and put forward an array of proposals for both day and night fighters, starting in February 1947, when they first proposed their night fighter, the P.228, a design that was essentially a tandem-seat Meteor with a pair of Rolls-Royce AJ65 engines mounted in a slight swept wings. However, 2 months later, they proposed the P240, featuring modified wings with less aspect ratio and more sweep on the leading edge, with engines moved to the side of the fuselage and a tailplane mounted higher on the fin. As for dayfighter specification F.43-46, they offered up the P234. This was to be a single-seat delta-winged interceptor with an unusual Delta Butterfly V-tail, with a pair of Rolls-Royce AJ65s buried inside the fuselage, with large air intakes, and the 4.5-inch recoilless gun mentioned earlier mounted on the underside along the center line. P.234 morphed into the P.258 and then the P.259. Gloster continued to modify their designs for the day fighter until their final proposal, the P.275, before they ultimately decided to drop the whole idea and focus their efforts on the two-seat night all-weather interceptor project. Ultimately, the day fighter went on to become the Hawker Hunter, and this is where we will leave the F.43-46 behind. So, back to the night fighter. In 1948, the F.44-46 requirement was superseded by specification F.4-48 to reflect the ever-changing requirements to meet the needs of the Air Ministry, particularly regarding radar and armaments. This specification now required a jet with a minimum top speed of 605 miles an hour, a climb rate of 1,000 feet per minute at 40,000 feet, be armed with 4 Aiden 30mm cannons and an A1 Mark 9 intercept radar. Gloster put forward the P272, which was the first design that started to resemble the future Javelin and was to be powered by either a pair of Rolls-Royce AJ65 Avon engines, then developing 6,500 pounds of thrust, or 2 Metrovic, each producing 7,000 pounds of thrust. Later on, Armstrong Whitworth would take over development of the Metrovic engines, which ultimately became known as the Sapphire. The P272 was to have delta wings with rotating wingtip controls instead of ailerons, and a slab delta tailplane. But the P272 turned out to be big, bulky, and heavy, weighing in at 25,500 pounds, a huge 5,000 pounds over earlier designs, and thus wouldn't be able to reach 45,000 feet in under 10 minutes without reheat. So, back to the drawing board, from which came some interesting proposals, including ones with 3 or 4 engines, and even one with a single Rolls-Royce Avon engine and 2 rocket motors. After much wind tunnel testing was carried out, they trimmed down the P272, and a few tweaks later, a final revision to the proposal from Gloster came with the P-280, which was the design to resemble what would become the Javelin most closely, with a wing area of 900 square feet, have a top speed of 685 miles an hour, and be powered by a pair of 7,500-pound thrust Armstrong Whitworth Sapphire SA2 engines, which were chosen due to their greater thrust over the Avons, a choice that would turn out to be for the best due to their reliability. Armament would consist of 4 30mm Aiden cannons or Blue Jay, later Fire Street guided weapons, and 2 Aidens. Finally, in early 1949, after many designs and revisions, Gloster was awarded a contract to build 4 prototypes of their F4-48 designs, plus 1 airframe for structural testing. This order was seen as insurance against the competing de Havilland DH-110, which was considered the preferable option due to it being a more conventional design and simpler to build. However, for the sake of accuracy, due to political dithering and cost-cutting, the already pitiful Gloster contract of 4 aircraft was reduced to just a pair of prototypes at the end of 1949. But when the impossibility of performing all the development flying on just 2 aircraft dawned on the government officials, the order was increased to 5 F4-48 prototypes, and 1 prototype of a trainer version. It is fair to say that these indecisions and political ineptitude caused valuable development time and most likely delayed the aircraft's entry into service by many months. So much so that the first production aircraft was built before all the prototypes had been completed. The de Havilland DH-110 was also victim to indecisiveness. With the number of prototypes which were to be produced at one point, they had 13 prototypes on order. But for the time being, due to cost-cutting, only 2 prototypes were to fly. More than any country, the UK adopted the delta wing design, even though the handling behavior of this form was not completely understood. Research undertaken by aircraft such as the Bolt & Pull P111 and P120 would provide valuable information, but delays meant that by the time the research data was available, it was too late, seeing that the first prototype GA5, as the aircraft was now called, had been under construction since April 1949 and was starting to take shape. The first aircraft, WD-804 and WD-808, the second prototype, were both assembled in sections at Gloster's experimental department at Bentham, although much of the manufacturing was carried out in the Gloster factory in Huckleycote. In the event you are wondering why Gloster was seemingly fixated on the delta wing, since there were so many unknowns regarding the handling characteristics, well, first of all, from a structural point of view, it would give the aircraft low structural weight with maximum wing stiffness in bending and torsion. The large wing area would also be good for carrying more fuel and equipment and for high-altitude performance, along with the sharp sweep back being ideal for high-speed flight. The tailplane also followed the same shape as the wings, as it was considered necessary to help make her more maneuverable at high speeds and controllable at low speeds, which reduced the angle of attack on approach, which helped hugely when landing in darkness. However, the delta wings did have some disadvantages, such as poor lift-to-drag ratio in low-speed flight and susceptibility to wind gusts when flown at high speed and low level. By February 1950, the structural work was well underway and completed a year later, in 1951. The basic layout of the GA5 closely resembling the P280 design. She was of a more conventional metal layout with a total of 12 fuel tanks, 5 fitted inside each inboard wing and 2 more fitted in the forward fuselage. The rear cockpit of the early designs was covered with a solid metal canopy with only 2 small portholes on either side so that the observer could see the dim radar screen. I have read that this arrangement was also chosen so that the navigator could concentrate on his radar more effectively. One almost feels sorry for the navigator here, and definitely for the observer in the Sea Vixen. The first prototype, WD-804, still a bare shell of an aircraft with no radar or weapons, was taken to bits and moved by road to the airfield at Moreton Valence in July 1951 on a Sunday, I believe to avoid traffic and the prying eyes of the public. where she was reassembled and prepared with the usual flight test instruments and an anti-spin parachute in a housing on the top of the tailplane. Despite wanting to keep the GA5 under wraps, the main road was only 100 yards from the runway threshold, attracting press and locals armed with cameras and binoculars. Who could blame them? So much for trying to keep it a secret. And so under the gaze of the sightseers, she began a month of ground testing and taxiing trials, which included 30 high-speed runs to iron out any creases. At last, on the 26th of November 1951, a clear, cold afternoon with Gloster Chief Test Pilot Squadron Leader W.A. Bill Waterton at the controls took off on her maiden flight. After her first flight, which lasted 34 minutes, Bill Waterton was asked what it was like to fly a 30,000-pound jet with a delta wing, to which he apparently replied, "Oh, she goes up, she goes down." He later wrote in his pilot notes, "The GA5 has proven relatively viceless with excellent stall warning and no real peculiarities, and in many ways not unlike a Mark 1 Anson." A remark that some have said was a veiled jab at the aircraft. If it were, it would not be his last. However, just like her development, the first flight was not without drama, as it was found that at speeds above 200 miles an hour, there was quite a bit of vibration coming from the rear end that could be felt throughout the whole airframe, and it was severe enough that the pilot of the Meteor chase plane could see the rudder being buffeted, at which point Waterton wisely throttled back. Subsequent flights with wool tufts stuck to the airframe showed vertical airflows over part of the fin, confirming the engineer's suspicion, which had been raised after seeing the path that streaks of oil leaking from the Sapphires had made. Now, usually escaping oil is something that ought to be avoided in aircraft. However, the Sapphire engines were lubricated on a total loss system that allowed oil to escape through two vents exhausting just aft of the jet pipe nozzles and below the rudder. It was this oil streaked across the bottom part of the rudder that helped diagnose the buffet as being caused by the airflow mixing with the jet exhaust over the rear fuselage. This problem was overcome by lengthening the jet pipes, which helped but was not cured until a fairing was fitted at the top of the jet pipes to separate the hot gas and airflows more effectively. The fairing is what gave the Javelin the familiar pen nib shape and was present on all Marks up to the FAW Mark 7, which had different engines. After this relatively simple fix and one or two other tweaks to the tailplane, the prototype continued flight testing, and by the end of June 1952, had completed 98 test flights, being flown at all altitudes up to 43,000 feet, and had reached Mach 0.915 in level flight. But she was still far from the finished article, as her power-assisted controls still required further fine-tuning. Although the GA5 was reportedly easy to fly, she did have some characteristics which would bite the unsuspecting pilot. For instance, the nose would pitch up significantly when the flaps were lowered on approach, requiring the pilot to push the stick forward sharply and dial in a lot of tailplane trim. She was also said to be tiring to fly, and needed a lot of tail trim with both hands on the control column. At this time, the rivalry between Gloster and de Havilland was heating up. The Ministry of Supply had started a competitive analysis of the GA5 and the DH-110, which had first flown 2 months before the Gloster aircraft, with the de Havilland test pilots referring to the future Javelin by all manner of ungentlemanly terms. Although the DH-110 was at the time considered to be the better aircraft, the delta-winged Javelin seemed to represent the start of a new era, whereas the swept-wing, twin-boom layout of the de Havilland aircraft was considered to have reached its development potential. So where previously the Gloster aircraft was seen as insurance against issues with the DH-110, now found itself on equal footing. On the 29th of June, Bill Waterton at the controls of WD-804 on her 99th flight, this time to test high-speed flight at low altitudes. Everything was going smoothly until he started accelerating past 560 knots, when he felt a small bump, followed by the aircraft starting to pitch up and down, rattle and buffet, and before he could decelerate, there were two loud cracks that ended the noise and vibration. The WD-804 had just lost both of her elevators. Due to the generous tailplane area, Bill Waterton was able to control WD-804, managing to bring the prototype down using nothing but trim and throttles to control pitch. It cannot be underestimated what a feat of flying this was, since the trim wheel was not designed to affect large changes in pitch. After a few attempted practice approaches and landings on clouds, he decided to land at Boscombe Down on their 10,000-foot long runway, where it bounced a few times, which broke the port landing gear, puncturing a fuel tank and causing WD-804 to burst into flames. She then skidded off the runway and came to a rest on the grass. Waterton escaped with his life and the valuable black box data recorder. Bill Waterton was awarded the George Medal for his act, although this incident put him at odds with the company and the aeroplane. Later on, a farmer found the missing elevators from the GA5. Investigations into the accident showed that the flutter was the highest rate ever recorded at 22 cycles per second. A replacement XD-158 was ordered immediately after the crash, becoming the sixth prototype and the FAW Mark II test aircraft. During this time, the ongoing Korean War meant that the British government faced an urgent need for combat jets, and undeterred by the loss of WD-804, the Ministry of Supply, just 8 days after the crash, placed a substantial super priority order for 200 Javelins over the rival DH-110, which the RAF had dropped. However, the DH-110 would ultimately become the iconic Royal Navy Sea Vixen. This super priority order meant that all of the work was halted, and all skilled engineers, tools, and materials were focused on the most critical projects that were given maximum urgency. It was around the same time that the GA5 was christened the Javelin, prompting some cynics to remark, "But a Javelin is a long-range fighting weapon," as a jab towards the GA5's limited fuel capacity and range. This order must have spurred Gloster to finish the construction of the second Javelin prototype, WD-808, which was to be externally similar to WD-804, but this time fitted with an anti-spin parachute and powered by the more powerful AS-A6 Sapphires, each developing 8,200 pounds of thrust. Interestingly, because the cause of the flutter that caused the WD-804 crash was still unknown, the Javelin was the first British aircraft to be fitted with a resonance system. WD-808, which had made her first flight on the 20th of August 1952, spent most of the year being prepared to investigate the buffeting and vibrations which had led to the loss of WD-804. And when she flew at the Farnborough Air Show, the air display was deliberately kept as tame as possible, flying low and slow, although the flying wedge still managed to impress the spectators with a roll to which one of the Gloster VIPs commented, "My God, it's like watching the bloody Albert Memorial roll over." At the time, as part of the USAF evaluation of European aircraft, WD-808 was test flown by a US crew, which earned her praise from American pilots as a very stable gun platform. The evaluation resulted in the US government allocating nearly £37 million under the Mutual Defense Aid Program, much of which went to purchasing the Javelin for the RAF. Thanks, Uncle Sam. But it was not all handshakes, backslaps, and medals all around. The US pilots, together with Bill Waterton, were critical that such a large aircraft with sizable wings could only carry 765 gallons of fuel, which limited sortie times to just less than an hour. This led to WT-827, the third prototype being fitted with a pair of 250-gallon ventral tanks that became known as bosom tanks. Despite increasing range, the drag and weight of these external tanks had a negative effect on performance at higher altitudes, especially above 40,000 feet. Since the Javelin was expected to spend most of its time at high altitude, it was fairly critical that she remained maneuverable. During wind tunnel tests and flight trials, it was discovered that the straight leading edges of the prototypes were prone to tip stalling at high subsonic speeds. Engineers found that the wing could be modified to increase lift at the wingtips and improve maneuverability by adding a slight kink to the leading edge and reducing the amount of sweep at the midway point, just past the cannon installation. Also, the fin and tail plane was strengthened along with increasing the elevator boost, which helped reduce the heavy stick forces pilots reported at high speeds and improve handling. These modifications were adopted in all subsequent Javelins, but it was not until the FAW-5 version that the limited volume of internal fuel capacity would be addressed. On the 11th of June, with her new wings, WD-808 was being flown by Gloster's Deputy Chief Test Pilot, Commander Peter Lawrence, who was on his second flight of the day in the process of testing the handling qualities of the new modified wings. To examine the stalling characteristics, the jet had the center of gravity further aft than had been previously tried, with the nose at a high incidence of 50 degrees. However, in this flight configuration profile, the large delta wings of the jet blanketed the airflow over the tail and elevators, and with no airflow over the tail surfaces and no pitch control, coupled with the aerodynamic center of pressure shifting forward of the center of gravity due to lack of lift from the tail, put the aircraft out of balance, causing her to pitch up uncontrollably, causing WD-808 to stall. The recovered data recorder showed that the aircraft plummeted almost vertically. Eyewitnesses reported seeing the aircraft in a tight left-hand spin with very little forward airspeed. It took less than a minute for WD-808 to fall 11,000 feet. The final radio call from Commander Lawrence was, "I'm in trouble." Later spinning tests in the Javelin was said to be a frightening experience for the unprepared. Although the spin was slow, the nose would pitch 70 degrees through each turn and would drop nearly 250 feet per second. These spinning tests were carried out by dropping a 6-foot scale model spun on a turntable beneath a balloon. These models were fitted with little electric motors to power the flight controls and a parachute to reuse the model. What was tragic about this crash was that Commander Lawrence could have ejected and saved himself. However, he deliberately remained in the aircraft, fighting all the way down, intending to avoid people and homes as he descended. He realized he was over a playing field at Flax Burton near Bristol where children were playing cricket, so instead of saving himself, he stayed with the jet down to 250 feet before ejecting. Unfortunately, he was too low for his parachute to open properly. His body, still strapped to the ejector seat, was found near the wreckage. It has been said that heroes are not made, but are born out of the circumstances in which they find themselves. The death of Commander Lawrence set in motion an investigation into what caused the accident, and also the stalling characteristics of the Javelin. Since the Javelin was fitted with an automatic observer, the engineers could figure out from the data what they believed had caused the crash. Gloster determined that at high angles of attack and speeds less than 80 knots, with the very large flaps deployed, the jet would enter a deep stall or superstall, and in nose high altitudes, there would be little or no workable airflow over the tail to push the nose down to allow recovery, a problem that affected other T-tail aircraft, particularly the BAC-111 and Hawker Siddeley Trident airliners. Later on, service experience would show that a fully stalled Javelin or one in a flat spin could fall almost 15,000 feet per minute. Now that the engineers had discovered the cause, they worked on fitting slotted flaps, which reduced the nose-up trim change when flaps were deployed. Gloster also added drooped leading-edge slats that were fitted and tested on trial aircraft XA-548 that proved to work well. However, the Air Ministry rejected them as a solution due to the 400 pounds of additional weight they added. In the meantime, Gloster advised their test pilots to only use flaps within certain combinations of flight conditions and speed, and were prohibited from performing looping maneuvers. The crews were also warned that should they find themselves in a similar position to bail out if recovery was not possible, and before they lost too much altitude. However, worryingly, wind tunnel tests also showed that the canopy was difficult to release at high angles of attack, after which the Air Ministry began to press for a power-assisted hood jettison mechanism. Despite the changes, some at Gloster felt that the super stall issue was never correctly addressed. A few months before the loss of Commander Lawrence and WD-808, the third prototype, WT-827, had come off the production line in March 1953 and was the first airframe to be fitted with radar and 4 wing-mounted 30mm Aiden guns for armament trials, but also in-flight refueling tests. Initially, someone thought it would be a good idea to install the refueling probe on the starboard wing behind the pilot, making it difficult for him to see and almost impossible for him to spear the drogue floating about on the end of the tanker's refueling hose to his right and over his shoulder. More on this later on. Speaking of noses, WT-827 was fitted with an experimental bullnose radome, but problems with erosion from rain and hail, plus the poor adhesion of the neoprene protective skin, led to many experiments to find a better adhesive, which all failed. In the end, it was decided to try an alternate shape, which led to the development of the now distinctive needle-pointed nose, but turned out that the new nose was more effective from an electronic and aerodynamic point of view. Still, it's interesting that if the glue had been stronger, we'd have ended up with a blunt-nosed Javelin. However, it is worth pointing out that the radome shape differed slightly depending on whether they housed British or American radar. By July 1954, Bill Waterton had left Gloster after presenting to the management a list of grievances about pay, conditions, and the string of modifications it needed implementing on the Javelin. However, the Gloster management, rather than take his advice, decided that it would be best if they parted ways, and with that, he went to work with the Daily Express to put his writing skills to good use as their air correspondent, where his columns fearlessly criticized British aviation, its aircraft, and its seemingly cavalier attitude to test pilots' safety, with one article in particular aimed directly at the Javelin. The aircraft had long been the butt of many unkind comments, mainly around its long development time and dearth of results. Her speed, or lack thereof, was also brought into question, with some in the industry saying that the Javelin could not go supersonic, when the Hawker Hunter, Supermarine Swift, and the de Havilland DH-110 had all achieved Mach 1, albeit in shallow dives. Now, the story goes like this. To set the record straight, Wing Commander Richard Dicky Martin, who had succeeded Waterton as Gloster's chief test pilot, woke London up with an unmistakable double bang of an aircraft going supersonic on the night of July the 4th flying over the city, specifically Fleet Street, the home of British newspapers, leading some to speculate it was aimed at them. Though a source from Gloster, it was later revealed to the press that it was a Javelin on a routine night test flight. This incident was explained away by the government of the day, with one minister claiming that the aircraft had been cruising at high altitude and near the speed of sound when the pilot's oxygen supply failed. During the ensuing confusion, he inadvertently exceeded the speed of sound, causing the bang. Wing Commander Martin tried to make the excuse that he had accidentally slipped through the sound barrier. However, those familiar with the aircraft knew you could not accidentally slip through in a Javelin. I've read that the best way to go supersonic was to apply full throttle, push the nose down 45 degrees, and wait, and she would eventually go past Mach 1. So, I'll leave it up to you to decide whether this tale has any truth. Either way, the jibes of subsonic only came to an end. If Gloster had wanted to wake up an entire city, they only needed to park one on the outskirts and fire up her engines. The Javelin was a rowdy beast on the ground and in the air. I suppose the noise pollution was not high on the list of priorities after 6 years of war, but even so, Gloster flight test departments went out of their way to liaise with the local doctors, farmers, and clergy to avoid excessive engine running or flight testing at certain times, so as not to interrupt weddings, funerals, and such. During lambing season, the pilots would even stay clear of farms where flocks were raised. At Hucklecote and Moreton Valence, in an attempt to make life more tolerable for the local residents and for the Gloster employees, pens were constructed from 12 tons of steel and tens of thousands of bricks to reduce the noise, and were big enough to house a single Javelin. The fifth prototype to fly, WT-836, was the first to resemble the production Javelin FAW-1, with the all-clear Perspex canopy for the navigator position, which, as mentioned earlier, had on the previous prototypes been an enclosed rear cockpit with 2 small portholes kept deliberately dim so that the radar screen could be better seen. But after several changes, including square windows in WT-827, and with the advent of better and more visible displays, the need to have the navigator work in the gloom was redundant, and a fully glazed canopy was adopted for all production models. Plus, another set of eyes keeping a lookout would not be a bad thing. Also, the canopy's contour was raised to allow the crew to reach the ejection seat handles above their bone dome helmets. It was in WT-836 that a great deal of time was spent trying to develop the technique to recover from a spin. There was a disagreement between Gloster and the Royal Aircraft Establishment, who could not agree on which technique should be used, as the Javelin spin characteristics were unpredictable, with the direction of the spin often reversing. Ultimately, they decided that the best technique would be to deploy full opposite aileron and jam the stick forward, then wait for the Javelin to stop spinning. When the spin stopped, the nose would pitch down sharply and the speed would then increase. Now, the pilot only had to slowly pull up out of a dive. However, this technique was not always guaranteed to work. In 1962, another Javelin was lost in the North Sea due to a flat spin. Despite the pilot performing all the spin recovery steps by the book, the aircraft refused to respond. Both crew ejected. Unfortunately, the navigator was never found. WT-836 was followed 2 days later by XA-544, first flown by Dickie Martin on the 22nd of July 1954, and the first of 40 Javelin FAW-1 production aircraft to roll out of the Gloster factory in Hucklecote and delivered to the RAF. Here, she became their first advanced, fast, all-weather, around-the-clock, radar-equipped interceptor, conceived from the start to be armed with air-to-air missiles, and the first of the RAF's interceptors to be capable of routine air-to-air refueling. Of the 40 FAW-1s, 29 were only delivered to the RAF, and Gloster kept back 11 for additional testing, which shows that the initial number of prototypes ordered was insufficient. XA-544 was used for instrument and armament checks. The second aircraft, XA-545, was the first Javelin to feature an electrically powered all-flying tailplane in preparation for the future FAW-4. The third jet, XA-546, was fitted with the G Mark III navigation system. However, although the Javelins had been given certificates of airworthiness, they were not to be stalled until Gloster had figured out the correct spin recovery technique, which was at the time still ongoing with WT-836. Therefore, for the time being, pilots were prohibited from flying above 622 miles an hour or slower than 144 miles an hour. It is said that the Javelin could not be looped. Now, that's not technically true. It's not that the Javelin could not be looped, it could. It was down to the understanding of the pilot of how to loop the big bird correctly. It all boiled down to how the stall recovery system functioned, a system which was naturally designed to detect low speed and avoid a deep stall. When the stall detection system sensed that the aircraft was going too slow, it would push the control column forward to pitch the nose down. So during a loop, the Javelin would be traveling slowest at the top of the loop, inverted, and the last thing that any pilot wants at this point is for the stick to be pushed forward. So a pilot who understood this characteristic of the Javelin would pull the stick back as hard as they could to keep the aircraft coming around the loop, but this quirk was considered to be an unacceptable handling risk. Naturally, since looping was strictly forbidden, it was of course attempted by a few pilots out of mischief. However, should any pilot feel the need to loop the Javelin, they would first need at least 10,000 feet of altitude, preferably 20,000. An American exchange officer obtained special dispensation to perform a loop before returning home to the States, but if fate would have it, he stalled at the top of the loop and could not recover. Neither the pilot nor his navigator survived. However, one thing that pilots never wanted to attempt, even in mischief, was spinning the aircraft. This was simply verboten. The third production Javelin FAW-1 XA-546 and a pilot were lost to the dreaded flat spin in October 1954, which was being flown by Flight Lieutenant Robert James Ross in the process of testing trim settings. Only 9 minutes after taking off from Morton Valence, ATC received a radio call. Over 7 spinning, trying to recover. A few seconds later, a pilot from nearby Javelin heard Flight Lieutenant Ross call, throttling back, after which no further messages were received from the 33-year-old graduate of the Empire Test Pilot School. Eyewitnesses saw the Javelin spinning as she fell before impacting the sea. A search was carried out, which lasted 4 weeks,
but neither XA-546 nor Flight Lieutenant R.J. Ross were ever found. Although Javelin seemed as though she had been sent from the future, she was, in fact, of fairly conventional construction, being built mainly from aluminium alloy with some steel. In total, there were 9 versions of the Javelin, conveniently numbered 1 to 9. Most versions have an overall length of 56 feet 3 inches, with the FAW-9 being a little longer at 56 feet 9 inches. However, all 9 versions had a wingspan of 52 feet, with a wing area of 928 square feet, and fully loaded, the FAW-1 weighed in at 36,690 pounds, pretty much the same as a Lancaster bomber. The later FAW-9 would exceed 43,000 pounds. Undoubtedly a large and heavy aircraft, it was considered to be underpowered, built like a tank, and was said by some pilots to fly like one. The FAW-1 had a max speed of 621 miles an hour at 40,000 feet, and could get there in 9.8 minutes, with a max service ceiling of 52,000 feet. But with maximum effort, it could reach 55,000 feet. Compared to jet fighters of the day, the Javelin had quite long legs, sitting high above the ground, with the pilot eyeline being 11 feet up, and the tailplane measuring 16 feet tall. The crew had to use a specially designed ladder, where previously they had to climb up the left rear of the fuselage, where there is a pull-out step and handholds, hoist themselves up over the trailing edge, and walk up the slippery wing to get to their positions. The airframe was built as 4 separate sections bolted together, where the rear section could be detached to give easier access to the engine, and when needed, to remove the engine. Rails were fitted in the center fuselage so that they could be installed from the rear. The engines in the earlier Javelin were a pair of Sapphire SA-6 engines developing 8,150 pounds of thrust. Starting these engines was an interesting but somewhat dangerous procedure, which occasionally went horribly wrong. The engine starting procedure used a Mark 12 starter with a 6-inch cartridge filled with cordite. To start the Sapphires, a cartridge was fired electrically, and the expanding gases would be fed into a turbo starter that would spool the engines up to 2000 RPM before disengaging. The starting procedure gave off a nice big plume of black smoke that sometimes happened when the cartridges were fired. If all went well, the engines would start, but that was not always the case. In October 1962, XA-661, a FAW-5 of 11 Squadron, was instantly destroyed when the starting procedure went wrong. After the first cartridge failed to spool the engines, a second attempt was made after the ground crew inspected the jet for any signs of damage. Once they were satisfied, they gave the pilot the go-ahead to fire the second cartridge. At the moment he fired the cartridge, there was an explosion around the port engine. The pilot and navigator quickly made their escape as the ground crew attempted to fight the growing fire, but there was little they could do with their handheld fire extinguishers, and by the time the fire engines arrived, the Javelin was destroyed. Turns out, the turbo starter had completely failed, broken up, and punctured one of the fuel tanks, causing the fire. From what I have gathered, please correct me in the comments, the difficulties arose when the first cartridge didn't fire and the second cartridge was used. On returning from a flight, the ground crew would replace the one that had been fired. In some case, this would be the second cartridge, leaving the first failed cartridge in situ. The next crew would do exactly the same. So essentially, the first cartridge had been cooked many times, until the firing of the second cartridge ignited both together, causing the starter to disintegrate. XA-661 would not be the only Javelin to be destroyed due to a faulty Mark 12 starter. In later models, it was replaced with the Mark 14 starter that used a smaller cartridge but was just as precarious due to faulty contacts and the occasional bad cartridge, as was the case when Javelin FAW-8 XH-977 of 41 Squadron, after an unsuccessful start, was damaged, and only saved from complete destruction by the ground crew putting out the fire in time. FAW-1 was equipped with A1 Mark 17 S-band search lock-on and blind firing radar, which sent the azimuth or elevation display to the pilot's gun sight, so he could follow evading targets, and armed with 4 belt-fed 30mm Aiden cannons, each with 200 rounds per gun, could make confetti out of the Russian bombers. Interestingly, I read that it was thought that no guns should be fitted at one stage, with the Javelin relying wholly on air-to-air missiles. The first to receive the new FAW-1 was number 46 Squadron on the 24th of February 1956, delivered to Odderham by a ferry crew flown by Flight Sergeant Bob Hillard and Navigator Flight Sergeant Gray Murren, who arrived on time to the awaiting crowds thanks to Bob Hillard borrowing his wife's watch. It has been said that No. 46 Squadron was chosen to be the first to receive the Javelin on its introduction into service on no more substantial a qualification than the design of its emblem of 3 linked javelins, and so into service entered the first RAF interceptor that was prohibited from stalling and looping. Although the RAF had put in an order for 200 Javelins, there was little or no interest from foreign forces, except Belgium, but could never secure a single export order. This was probably due to the long development time caused by few prototypes, which were initially built to carry out all the flight and development work, and the lack of range of the earlier models. Just over 430 production aircraft were built across a total of 9 marks, from the previous FAW-1 all the way to the FAW-9. Each mark was slightly different, and modified in some way to create a new version. I had a lot of fun researching these various marks. Each one could have been an entire video on its own. However, I have maintained the focus on the most salient points, so let's go. The FAW-2 first flew on the 31st of October 1955, with the first production aircraft taking to the air on the 25th of April 1956. It was essentially the FAW-1 except for some changes, including being fitted with the all-flying tailplane and changing the radar for the American APQ-43 unit, named the A1 Mark 22 in RAF service. These versions had a stall warner fitted to set off a buzzer in the cockpit at the onset of a stall. From my research, it seems that prior to the stall warner, pilots would anticipate the stall by feeling the judder, which signifies the onset of the stall. Correct me if I'm wrong, scant info regarding when the stall warner was first introduced is available, and what I did find was contradictory. However, the stall warner and judder from the wings gave the pilot ample warning that he had reached the limiting angle of attack. The performance figures for the FAW-2 were similar to the FAW-1, although being about 500 pounds heavier, with a max speed of 621 miles an hour at 40,000 feet, which it could reach in 9.8 minutes with a max service ceiling of 52,000 feet and an absolute ceiling of 55,000 feet. The AI-22 radar was slightly smaller than the AI-17 unit in the FAW-1, which had a range of 20 miles and prone to malfunctioning. Although smaller, the new equipment required a larger hinged radome that swung out rather than being removed for access. 26 of the 30 Mark IIs went to No. 46 Squadron to replace their Javelin 1s. Some also went to equip No. 85 and 89 Squadrons, whereas the remaining 4 were assigned to various development programs. Despite the size and complexity of the Javelin, early conversion training carried out by the No. 46 Squadron was done by sending its commanding officer and flight officer to Bossum Down to get trained up and get experience on the Javelin. Once they returned home to Oddam, they would train the squadron's pilots when their first taste of the Javelin would be from sitting in the navigator's seat, peering over to see what was going on in the office. The pilot would talk them through the various controls and how far they could fly in the stall judder, as the FAW-1 had no stall warner, and after around 6-day sorties and 1 night sortie, followed by a flick through the pilot's notes, they would swap seats and go solo, at which point they would be considered operational on type. Training crew like this was not ideal, so a dual-control trainer version, the T Mark III, was developed to speed up operational conversions. The fuselage was extended by 44 inches to balance the aircraft, since the heavy radar was removed and replaced with a small ranging set. The new section was also home to a pair of 50-gallon fuel tanks to increase instruction time per flight, although all this additional weight made the Mark III a sluggish aircraft compared to the original Javelins. It would take the Mark III 22 minutes to climb up to 45,000 feet, compared to the 10 or so minutes taken by the FAW-1. The performance figures for the FAW-3 were much more conservative due to its greater weight of 42,000 pounds fully loaded, with a top speed of 600 miles an hour at 35,000 feet, a max service ceiling of 46,000 feet, and an absolute ceiling of only 500 feet more. A larger canopy was installed to accommodate the rear seat, which was raised by 9 inches to give the instructor a good view forward over the student pilot's head. It also included a second set of controls. The Mark III kept the 4 wing-mounted 30mm cannons for gunnery instruction. The Mark III can be identified by the two protruding periscopes on either side of the fuselage that the instructor used to help the student pilot aim the cannons. 22 of these Mark IIIs were built and distributed across the various squadrons operating Javelins. The first of 50 FAW-4 flew on the 19th of September and was a Mark I fitted with Sapphire SA-6 engines and with a hydraulically operated all-flying tail. The wings were also modified with 2 rows of vortex generators on the outer leading edges of the wings to reduce the effect of shock waves and improve stalling characteristics. These were installed on all future Javelin versions. The Mark IV weighed in at around 33,150 pounds, just 500 pounds more than the FAW-1, and could intercept targets at 632 miles an hour at 40,000 feet, with the AI-17 radar with assistance from the ground, and fly past Mark I in a shallow dive from 45,000 feet, an altitude which it could reach in 8 minutes. Number 141 Squadron, temporarily based at St. Faith, was the first to receive the new Mark IV. The Mark V, of which 64 were built, was externally identical to the Mark IV with the flying tail and AI-17 radar. If you recall earlier in the video, I mentioned that the Javelin was criticized for her lack of range and sorties time sometimes limited to only 45 to 50 minutes when operating without external fuel tanks. So to fix this, the FAW-5 had a newly designed wing that could carry an additional 250 gallons of internal fuel. The wing redesign involved changing the shape and position of 5 existing fuel tanks in each wing. Her increased range meant that this Mark was in service longer than the previous versions. With full fuel and a full load of ammunition, the takeoff run was slightly longer than the FAW-4, but was still under 1,000 meters. The performance figures for the FAW-5 were a little lower than the previous Mark IV, mostly due to being about 2,000 pounds heavier at 39,370 pounds fully loaded. This extra weight meant her max speed at 40,000 feet was 615 miles an hour. Consequently, it took her a little over 10 minutes to reach 45,000 feet. This version was the first Javelin variant with the ability to carry 4 Firestreak missiles, although I don't believe she ever did. They were first delivered to number 151 Squadron, based at Leutches in 1957. The Mark VI was essentially a Mark V with the same modifications that turned a Mark IV into a Mark V. The Mark VI sported a new American A122 radar with a shorter radome and the modified wing with increased fuel capacity. The performance figures for the FAW-6 were similar to the FAW-5, despite being around 1,200 pounds heavier, but still had the same max speed of 621 miles an hour at 40,000 feet, and also took her a little over 10 minutes to reach 45,000 feet. 33 Mark VI Javelins were built, with the first going to number 89 Squadron in 1957, but had a relatively short service life, and were replaced by the Mark 8s and 9s. The Mark VII version was given the most significant upgrades compared to her predecessors, and was also the most produced, with 142 being built, 85 by Gloster and 57 by Armstrong Whitworth at Coventry. The Mark VII got a fully powered hydraulically operated rudder, a pitch auto-stabilization system, and an autopilot, as well as retaining the AI-17 radar, able to pick up targets 15 to 20 miles out. The Mark VII was also when she got a new set of engines, being fitted with a pair of uprated 11,000 pound of thrust Sapphire SA-7 engines, a 40% increase over the earlier Javelins, along with different nozzles and an extended rear fuselage to help reduce drag. These engines significantly improved climb performance. The extra power would get her to 45,000 feet in 6.6 minutes, which was a very impressive rate of climb, with a max speed at that altitude of 620 miles an hour, making it more likely that the Mark VII would intercept Soviet bombers before they reached UK airspace. The Mark VII was armed with 4 30mm Aidens and was the first RAF interceptor to enter squadron service armed with air-to-air missiles, being able to carry 4 of the infrared homing Firestreak missiles. Apparently, it was said that the airflow over the 4 very large Aiden gun ports in the wings, which I was able to fit my entire hand, produced an organ-like noise, and combined with the roar of the engines, gave the Javelin a unique throaty howl, which earned it the nickname the Harmonious Dragmaster. In place of the missiles, the Javelin could carry 4 100-gallon drop tanks on the wing pylons. The Mark 7 first flew in November 1957 and was sent to No. 33 Squadron in July 1958. The Mark 8 was the last newly built production Javelins and the ultimate variant, of which 47 were built. It was first flown in May 1958 and was essentially a Mark 6 with 11,000-pound thrust Sapphire SA-7 engines, but modified with a rudimentary reheat system capable of producing 12,300 pounds of thrust, now named SA-7R, which did away with the cartridge starter system, instead using liquid fuel engine starting system. These new engines also improved the Javelin's already fairly impressive climb rate, as it could now reach 40,000 feet in 4 minutes. The first 20,000 feet was reached without reheat, after which the pilot lit the reheat and covered the final 20,000 feet in 90 seconds, and could carry on to 50,000 feet, getting there in a little over 9 minutes. In reality, the reheat was installed to overcome the performance penalty of carrying the 4 300-pound Firestreak missiles under the wings. But the reheat was really only effective above 20,000 feet due to how the system functioned. At altitude, the engines required less fuel than the fuel pump could provide, so the surplus fuel was fed into the jet pipe, providing additional thrust that was very useful in overcoming the drag caused by the missiles. However, at lower altitudes, the engines consumed the fuel at around the same rate that the fuel pump could supply, and therefore there was little surplus fuel that could be spared for reheat. But since the reheat system had priority, it meant that if the pilot selected reheat below 20,000 feet, it would lose up to 10% engine RPM, and consequently, the aircraft would lose speed. Interestingly, when the pilot selected the reheat at lower altitudes, it produced a thunderous roar. This trick was used during the troubles in the Far East as a frightener. It was employed to great effect in Borneo to keep the communists at bay, where the Javelin pilots used to fly up and down a few miles behind the front line and light the reheat, making a big boom which made the communists think the British had artillery nearby. This version of the Javelin was a complexly different beast than the one which first entered service with No. 46 Squadron. The Mark 8 could outperform the Hawker Hunter in many respects, carry a greater weapons load, and climb to operating altitude, which could be as high as 50,000 feet, very quickly. The Mark 8 was also fitted with a Sperry autopilot that worked with the AI-22 radar, which together could automatically complete an interception without the crew seeing the target. I have read that the system, when it worked, was able to find a penny in the fog. The last Javelin of this production batch, XJ-165, left the factory in Hucklecote in August 1960, and was the last aircraft to be built by Glosters. No. 41 Squadron was the first to receive the new FAW-8 in the spring of 1960, followed by No. 23, 72, and 85. FAW-9 was not, in spite of a unique designation, a new variant, but instead was the FAW-7 converted to take the Sapphire SA-7R reheat engines. And this decision was made to improve the handling of the FAW-7, where they certainly enhance the climb rate and improve turning performance at high altitudes, up to 50,000 feet. Although it was not a simple case of unscrewing a few bolts and swapping out the engines, the conversion process took hundreds of man-hours to break the airframe down into its major components, with improvements being made to the wings, such as having the slightly drooped leading edge like that of the FAW-8. The new engines also meant that they got the new liquid fuel starting system, engine de-icing, and improved windscreen rain dispersal system that blew hot air over the front windscreen. On earlier Javelins, a serious design flaw caused rain on the windscreen to obliterate all forward vision, something that was fairly dangerous, especially at night. The FAW-9 also got every gadget going: vortex generators everywhere, a fully powered rudder, an improved tailplane trimming system, and new Martin Baker 3JS ejection seats. All in all, 76 FAW-7s were converted to become FAW-9s. At this time, RAF bases closing around the world raised the need for an aircraft with greater range, So it was decided to pick up on the previously unsatisfactory refueling tests until a workable in-flight refueling system took the shape of a 20-foot-long lance-like probe on the right side of the fuselage that could be quickly installed, making the Javelin available for long-range ferrying in just a few hours. The long probe extended beyond the nose, looking like a medieval jousting lance was fitted to the fuselage of 22 Javelin FAW-9s. These modified Javelins were also modified to carry up to 4 230-gallon underwing drop tanks fitted to the missile pylons and were designated FAW-9R, the R for range. However, it was not uncommon for the Javelin to be flown with only 2 of the tanks to reduce drag. The first of these modified FAW-7s entered service with number 25 Squadron, and subsequently number 23, 29, 33, 60, and 64 squadrons. In 1960, with a refueling from a Valiant tanker, enabled 4 Javelins from 23 Squadron to fly non-stop from the UK to Singapore, a distance of 7,500 miles, which must have got a long way to demonstrate to the world the ability of the RAF to deploy anywhere in the world. The early models of the FAW-1 were fitted with Martin Baker Mark IIIJ ejection seats with 2 firing handles, which, when pulled, would jettison the canopy, followed by the seat. There were several cases where the pilots were unexpectedly ejected from the Javelin due to an incorrectly assembled top lock, which meant that the seat was not correctly locked to the aircraft. This caused the seat to lift under even slightly negative Gs, which caused the drogue gun to fire through the canopy, pulling out the drogue chute, which started the sequence that ejected the pilot out through the canopy. One such instance of a pilot being inadvertently ejected happened on the 26th of February 1958, when FAW-7 XH714 was being flown by Flight Lieutenant May on a routine flight following a major service when his ejector seat malfunctioned and was ejected from the aircraft at 5,000 feet while traveling 400 knots. His seat struck the tail and fin, causing such damage to it that the right lap strap lock failed to disengage, and the seat flailed around him as he fell, although his parachute did deploy, and it did so only partly. Without the pilot, the Javelin was sent into a spiral dive, but due to severe buffeting in the rear cockpit, the navigator, Flight Officer Coates, only managed to eject at 2,000 feet. Unfortunately, his seat also impacted the side of the aircraft, which caused a delay in his parachute from deploying. Neither man survived. Another instance of an incorrectly installed top lock of the ejection seat causing the pilot to be ejected happened on the 18th of February 1959, when Flight Lieutenant Carey of 87 Squadron was flying FAW-1 XA569 on a high-altitude training flight over Germany. In a letter to Flight International magazine, he describes the experience. "I had a very rough ride in the ejection seat down to the auto-separation altitude. The drogue assembly had been damaged in exiting through the plexiglass canopy, with the result that the seat was spinning and somersaulting all the way down from 42,000 feet. My relief when the automatics operated perfectly turned to consternation when I pitched forward, not only out of the seat, but also out of my parachute harness. Luckily for me, one of the thigh straps jammed in the crotch loop, and I ended up at 10,000 feet hanging upside down by one leg. I must confess that this was a bad moment. By holding myself upright by the dinghy pack, I was able to hook my arm through the harness and clasp my hands together before the jammed thigh strap gave away. By the time I landed on a small island in the Scheldt estuary, I seemed to have been hanging from that arm for a very long time." Unfortunately, his navigator, Flight Lieutenant Alec Cooper, did not survive. In the early days of the Javelin, many aircraft were mysteriously lost. It took some time to determine the exact cause of these losses, since vital evidence was destroyed in the post-crash fires. Oftentimes, in the early days, crews and aircraft were lost over the sea, and all that was known was that the aircraft had unexpectedly exploded, giving the crew no time to send a message out. It was discovered that in particular situations, when the Javelin was flying through cumulonimbus clouds, that if enough supercooled water droplets were to be sucked into the engines, it would cause the casing to shrink and come into contact with the compressor blades, which then broke up in a violent explosion, and because the two engines were set close together with gearboxes, electrical and hydraulic systems in the middle, the explosion would also take out the nearby systems. This phenomenon became known as centerline closure. That would be the Javelin's Achilles heel, and it was experienced by the crew of a Javelin FAW-7 on the 9th of July, when they flew into dense cumulonimbus at 8,000 feet, when the aircraft was struck by lightning, followed by a few seconds later by a violent thump and explosion causing the Javelin to spin out of control. Both crew ejected safely, with the Javelin hitting the ground near Horsham St. Faith. The investigation following the crash showed considerable damage to the compressor, with blades having been shot through the engine casing, some of which were found over a mile away. At this point, there was disagreement between Gloster and the Air Investigation Branch regarding what had caused the compressor to fail. Gloster was of the opinion that the weather conditions had played a role in the starboard engine failure, whereas the Air Investigation Branch pointed out 2 prior incidents where the compressor had failed and the weather had not played a part. Ultimately, the solutions were a bit of a bodge. Firstly, a wire mesh arrangement was installed around the compressor disc to prevent shed blades from escaping and damaging more vital parts. This was until it was decided to line the compressor casing with an abrasive material so that when the blades touched the outer casing, they gradually wore down. The result was that the engine kept going, but produced less power. However, the modifications to the compressor casing was not an overnight task, and during this time, other Javelins were lost. On the 5th of November 1963, a Javelin crashed due to centerline closure when a pair of Javelin Mark IIIs out of Orange, France, on the way back to the UK, were at the time climbing to 24,000 feet through layers of cloud, which became thicker above 15,000 feet with continuous rain. On reaching 24,000 feet, the Javelin, which was flown by Flight Lieutenant Holman, suffered an engine failure, and while he was dealing with that, the other engine failed. He attempted to turn around and land back at the airfield, but with the high rate of descent, it would be impossible. So the crew elected to eject at 6,000 feet into a thunderstorm, both surviving with slight injuries. However, the Javelin came down on a row of houses near Saujac. 4 people died, with 9 being injured. The question surrounding the Javelin has always been what she was like to fly. Well, this was an interesting part of researching for this video. It's a fairly mixed bag. Some pilots liked the Javelin, whereas some never got on with her. However, she never seemed to endear herself to the crews in the way which the Hawker Hunter did, and was more likely to inspire affection rather than confidence. It is important that we keep in mind that she was designed to be a bomber-destroyer, but along the way, she acquired a less than glamorous reputation, as she was prohibited from looping and stalling. But she was an interceptor, not a dogfighter. Her job was to get to high altitude as fast as possible, and shoot down bombers over the North Sea. But since the Javelin was named the Fighter All-Weather, the public took her to be a fighter. Had she been called the Interceptor All-Weather, then maybe, who knows. She was considered easy to fly for a big aircraft, with crews appreciating her roomy cockpit, well-displayed instruments, and good all-round visibility. On approach, pilots had to put her on the runway because her large wings provided sufficient hold-off. It was on the ground that pilots often found that the Javelin was a bit of a challenge, being tricky to steer with the toe brakes, often leading to many sneaking tire marks on the runway. She was more agile than she looked, and operated well at altitude thanks to her delta wings. The later marks, having a lot of power for the time, could put up a good fight against most contemporary aircraft. One pilot said, "It was really great to let a Hunter get airborne before you, pass him on the climb, and then sit at 45,000 feet waiting for him to come staggering up. And don't forget, we were the only aircraft to carry 4 missiles and guns." Above 20,000 feet, the Javelin also outturns the Hunter, holding her own against a smaller jet, although she falls short when going up against her rival, the Sea Vixen, which could fly slower and zigzag around the Javelin. But the Javelin did have 4 30mm cannons that the Sea Vixen did not. However, in one training exercise, a Vulcan managed to outturn a Mark 9 and end up on its tail. Although, in all fairness, the Vulcan was lightly loaded with minimum fuel. But a Firestreak armed Javelin would have taken out the Vulcan from around 3 miles. a handy safety margin to have if the Javelins ever had to go up against the Soviet Bears with their 20mm radar-laid guns before they got up close and personal. The Javelin did have one interesting trick up her sleeve. If she found herself on the wrong end of a dogfight, she could deploy her huge air brakes, which were about 2 feet by 8 feet on top and below each wing, and came out almost at right angles, while simultaneously closing the throttles. The effect of this would be like hitting the brakes on a car, causing the attacker to overshoot. And this maneuver was extremely useful in reducing the possibility of approaching too fast and overshooting an enemy bomber on dark nights, although given her size and radar signature, there was probably little chance of surprising her prey. Her large air brakes also allowed her to make some spectacularly rapid descents, going from 36,000 feet to the runway threshold from only 10 miles out, while maintaining a respectable rate of knots. Gloster considered the Javelin to be a supersonic aircraft, but only just, and as we saw earlier, was not supersonic in level flight. It says something about her engines considering her wings were as thick as doorsteps. Wing Commander Mike Dusty Miller suggested the best way to get a Javelin supersonic was to roll it on its back and pull, as that way it would accelerate quicker. These guys were an interesting breed, no doubt. Range and fuel load were always on the minds of those who flew her. Interestingly, the Javelin could be flown with one engine throttled back, but at a pinch, there was no problem in shutting one engine down and relighting it when needed. Many pilots considered the 4-gun FAW-7 to be the best of the many variants. The FAW-9 was a close second, only if she was not carting around the 4 300-pound Firestreak missiles under her wings. Pilots also had to be very careful when handling the FAW-9 above 50,000 feet, as steep turns while pulling 2G or more could bring the Javelin into the pre-stall buffet, which a skilled pilot could handle. Although at altitudes above 20,000 feet, she was limited to Mach 0.95, and if fitted with ventral tanks, pilots could not exceed 3Gs or 4Gs if empty. In the next part of the Gloster Javelin story, we will cover her service in the RAF, her role in overseas operations, how she almost got new wings to become a true supersonic aircraft, and her legacy. Thanks for watching, don't forget to leave a like and comment on the way out.